4.5, we've already looked at how to graph sine and cosine. In our next lesson, we'll be looking at how to graph their reciprocal trigonometric functions of cosecant and secant. Today, our focus is being able to graph the parent function of tangent and then transform it to do any phase shifts or changes to the amplitude or period and frequency. So we should be able to graph tangent, find its period and frequency, its phase shift, state any vertical shift, okay? And so for now, we're just focusing on tangent. But we will be coming back to sine, cosine, and tangent original functions as we then look at the reciprocal trigonometric functions. The tangent function is just f of x equals tangent of x, where x is in radians. Now we're going to start by looking at our unit circle. When we're on the unit circle, the value of tangent here is 0. I don't know what that is as a decimal value, so without a calculator I'm not going to be able to get it. But at pi over 4 it's 1. At pi over 2 it's undefined. At 0 it's 0. Where else are these numbers going to be exactly the same? 0, 1, and undefined. At what? Sorry. Quadrant 3. So at pi, at 5 pi over 4, we're going to get positive 1. And here we're going to get undefined again. So wait, it's going to repeat itself here. Did sine do that? Did sine repeat itself down here? No. Sine went from 1 down to 0, all the way down to negative 1, back up to 0, back up to 1. So it took how long to get sine to come back? Full circle, so that it oscillated between 1, or that's cosine. I'm sorry, I'm looking at cosine. That was cosine. It took full circle, 2 pi, to get all the way back. It went all the way down to negative 1 and back up to 1. Sine was the same thing. It went up and came back down to 0, but there had more to do. It had to go down to negative 1 and come back up to 0 to complete the full period or the full cycle. So that's for sine and cosine. Their period is 2 pi. What do you think the period for tangent is going to be? Any guesses? So look, it starts at 0, goes to undefined, comes back down to 0. Look here, it's repeating now. See, 0, 1, undefined, undefined, negative 1, 0. So is it going to be a full circle for tangent? Half circle. It's going to have a half circle. Now here's the other thing. Right now it's going to go from 0 and come back to 0 and have this undefined, this interruption in the graph. But there's going to be an interruption in the graph too. By the way, if it's undefined, what type of thing might we see at an undefined value? Think back to first semester. A hole, if it canceled out in a rational function, is the only time we see a hole, but that's a good guess. What else? A vertical asymptote. So this thing's going to have vertical asymptote, right? And do we want that halfway through the graph? Do we really want to break up the graph? No, I'd rather have a complete picture of the graph from vertical asymptote to vertical asymptote. So for tangent, we're actually going to start at negative pi over 2. So from 0, right, here's our initial ray, our terminal ray at negative pi over 2. Include the value of negative pi over 4, which is the same as pi over 4. Then 0, pi over 4, and pi over 2. That way we get an uninterrupted graph of tangent from negative pi over 2 to pi over 2, completing one full cycle, or one full period of it. And yes, there will be vertical asymptotes, so then we can start the next period of it over here, and just keep rotating around to get more periods of tangent. So it's important to note that the period of the tangent function, as you guys saw, for sine and cosine it's 2 pi. For tangent it's going to be just pi, half a unit circle. That's for the parent function. Now if we have any horizontal compressions or stretches, that'll change it, so it's pi over b. Remember, calculating the period of sine and cosine, we had 2 pi over b. For tangent, it is pi over b. So what would the frequency be? B over pi, correct. Just the reciprocal of the period. So we're going to look at a parent function for tangent, and then we'll use that to start doing some transformations. So we said we're going to start down here at negative pi over 2, then negative pi over 4, then 0, then pi over 4, and then pi over 2. The only two really strange ones, at least right now, for where we start is going to be tangent and eventually cotangent. But actually cotangent ends up working out okay. But right now sine and cosine, we just do 0 to 2 pi and then we get all our values. But for tangent, we do negative pi over 2 to pi over 2. At negative pi over 2, it is undefined. So same at pi over 2, that's why we wanted an uninterrupted graph, so we went from vertical asymptote to vertical asymptote. At pi over 4, the value is 1. At 0, the value of tangent 0. And at negative pi over 4, this is going to give us negative 1 when I divide the y over the x, or sine over cosine. Any questions where the table comes from? Okay, so now I'm going to graph that, and I'm just going to graph it on here. This is pi over 2, so this would be pi over 4. This is negative pi over 2. This would be negative pi over 4. At my pi over... Wait, what am I doing? I wrote those in the wrong spot. Sorry. Jeez. So our vertical asymptote is at negative pi over 2. And at pi over 2, we have two vertical asymptotes. One starting, and then this will be the start of the next tangent function. And then we have to plot points. So I have to plot at negative pi over 4, I have to go to negative 1. Then 0, 0. Pi over 4, I have to go to 1. Here's what the graph of tangent looks like. To the left of 0, it goes down and approaches that vertical asymptote. To the right of 0, it goes up and approaches the right side vertical asymptote. And we're going to see this will just keep repeating the same pattern to the left and right, because it's just going to keep going through the same cycle, right? When I get past pi over 2 here, it's going to, that was my undefined value, it's going to come up to negative 1, and then it's going to go to 0, and then it's going to go to 1, and then it's going to be undefined again. So it's going to repeat this same cycle. All right, locate the vertical asymptotes. That's going to be important, but we have to first figure out what the period is and figure out where the original vertical asymptotes are, or where the first one that we want to use is. So right now, is that 4 inside or outside of the tangent function? Inside. So is that going to affect the graph horizontally or vertically? Horizontally. It will be a horizontal compression of 1/4. So I'm going to start with my original table values for tangent, which are negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. The two ends are undefined, negative 1, 0, 1. So this is same again. I just got this from above, but I could have gotten it right from my unit circle again, going from negative pi over 2, negative pi over 4, up to pi over 2. We are supposed to take this and multiply the x-coordinate times 1/4. That's going to make this negative pi over 8, negative pi over 16, pi over 16, and pi over 8 for my x-coordinates. When I go to graph it, I'm going to want to see them evenly spaced, so I'm actually going to convert these all to 16ths. It'll just make it a little easier. That's going to make this negative 2 pi over 16, negative pi over 16, 0 pi over 16, 2 pi over 16. I can see they're evenly spaced still. I know I converted it correctly. Will the y-coordinate change based on the transformations done to this function? Nope. There's no vertical stretch or vertical shift up or down. So I'm going to start with these on my x-axis. I need everything in terms of 16ths, and I've got to be able to graph 2 periods of this, so I don't want to make it too big. I'm going to start probably here. That's going to make it bigger than I want it to. That's okay, we'll go to the right. We'll stretch our graph out a little bit if we have to. We'll make it go to here if we have to. So this is negative 2 pi over 16. That makes that pi over 16 0, or negative pi over 16. And that makes this 2 pi over 16. That makes this 3 and this 4 pi over 16. 5 and this 6 pi over 16. I'm going to plot these values at negative 2 pi over 16. I have to do the undefined vertical asymptote. And the same thing at 2 pi over 16. Notice there are 3 points between those, and when I have 3 tick marks equally spaced, I'm supposed to go negative 1, 0, and 1. Any questions so far? Yes, sir.
So just making sure, when you went from like negative pi over 8 to negative 2 pi over 16, you were just kind of both putting them with the same denominator?
Yes, I was converting that one and this one down here to the same denominator by multiplying by 2 over 2.
Okay.
So that it doesn't change the decimal value, but it changes the way it's represented so they have the same denominator.
Yeah.
Yeah. And then here is my graph, but that's only one period of pi, which we have to go through and state the period and all that stuff in a second. Notice these are equally spaced. They're each 1/16 away. So now I can continue this pattern. After a vertical asymptote, there's 1, 2, 3 points and another vertical asymptote for the graph of the tangent, as long as I keep them equally spaced. So the next one from this first one has to be down at negative 1. The second one over has to be at 0. The third one over has to be at 1. And the fourth one over, that's why it's the 6 pi over 16, it's 4 pi units over, 4 pi over 16 units over, is my next vertical asymptote. So I'm just repeating the pattern. If you wanted to, you could go in the negative direction. Negative 3, negative 4, negative 5, negative 6. Okay, and actually you'd only have to go to negative 4. So you'd have to do negative 3, negative 4. You actually have to do more than that. So we have this, and so now that we have our graph for this, we've got our 2 periods. The first vertical asymptote that's positive that I see is 2 pi over 16. You can reduce that if you want. I'm going to leave it as this. My vertical asymptote is 2 pi over 16. Technically, it should be pi over 8, but that's okay. I'll accept this. Plus another period, right? Because this vertical asymptote's repeating every period. It started here, it repeats. It repeats at the end of every period or the beginning of every period. So the period, though, for this, remember for tangent, it's pi over b. So since the period is pi over 4, we're going to have to add pi over 4 times n, pi over 4 times n, where n is an element of the integers. This tells me the location of all vertical asymptotes that you could ever possibly graph for this particular function of tangent. We've stated the period, we've stated all the vertical asymptotes, and we sketched 2 periods, so we are done with this particular problem. Any questions on how this was graphed? Yes, sir?
Why'd you put it over 4?
Because it's pi over b, and b is 4.
Okay.
Now, when I go to do it, when I go to use that multiplier on x, I have to flip it, because it's actually a horizontal compression of 1/4. But the actual value of b, as I see it in the equation, is 4.
Okay. And with, I understand how like this has the different periods and like we could see them distinctively because there's vertical asymptotes. But what about with sine and cosine?
Sine and cosine do not have any vertical asymptotes that we have to worry about. Now, their reciprocal functions, when we get there, we're not there yet. See how sine is 0 here? What's the reciprocal of 0 over, what's the reciprocal of 0? Undefined. So cosecant will have vertical asymptotes, but sine doesn't. So for sine and cosine, when we graphed those before, we just went from 0 to 2 pi and grabbed our quadrantal angles.
And there are only one full circle around the unit.
One full circle for the parent function,
Yeah.
which makes that 2 pi over b. If there's a value for b, it will change the period. If it's horizontally compressed or stretched. Horizontally compressed or horizontally stretched, it will change the period.
Okay, and with it being 1 or 2 pi over b,
Yes.
would it be oh, never mind, I remember now, because we graphed them and that's how we found out the
Yes.
period, right?
Yep. Yep. Well, we knew 2 pi and then we divided by the value of b. Taylor, did you have a question or no? No. Okay. All right. So this next one, is that 1/2 x, is that inside or outside the function? So it's actually a horizontal stretch of 2. Now that does mean, though, the value of b is 1/2. So my period, the period's going to be pi divided by 1/2, which is actually multiplied by the reciprocal of 2 over 1. So it's going to be 2 pi. Period will be 2 pi, which is bigger than it was before. Before it was just pi. On the parent function for this one, it will be 2 pi. So it's actually a horizontal stretch of 2. We can even see that in how the period is affected. So we're going to start with our original function for tangent. I keep writing it out to help me memorize it, to reinforce it. Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Undefined, undefined, negative 1, 0, 1. All that's happening is a horizontal stretch of 2, so we're supposed to do 2 times the x coordinate. That's going to give us negative pi over 2, 0, pi over 2, and pi. If you want to, these are only half a unit, so I'm not going to bother, but if you want, you can convert them all to halves. That would make this negative 2 pi over 2, and this 2 pi over 2. So we have pi. I'm not going to go out to the furthest point because I'm trying to get a second period in here if I can. And this is negative pi. There's negative pi over 2. Here's pi over 2. At pi and negative pi, we have vertical asymptotes. That's the undefined value. At negative pi over 2, we plot negative 1, 0, 0, pi over 2, 1. And then from 0, 0, it goes to the left, or goes down as it goes to the left and approaches that asymptote. From 0, 0, it goes, as we go to the right, it goes up and approaches that vertical asymptote. You can decide if you want to do one in the positive direction or in the negative direction, but if I already have the start, this vertical asymptote's the start of the next graph, of the next period, I just need 1, 2, 3 points equally spaced from that, and then another vertical asymptote. So there's 3 pi over 2 and 2 pi. That's 4. Here's 5 pi over 2 and 6 pi over 2, or 3 pi. So here I'm supposed to going to the right. From this one I had negative 1. From this one, 2 away is 0, 3 away is 1. And 4 away from this, if they're evenly spaced, is my next vertical asymptote. So that's at 3 pi. That one's at, this one's at pi. My first one is pi units away. My period is 2 pi. This means that my vertical asymptotes, the first one starting at pi, I'll just keep adding 2 pi to it, or subtracting 2 pi from it to get to the next one. And those are the only two things they asked for this function. Questions on that? So you can even see this is 2. There's 1, 2 pi units away before the next vertical asymptote. 1, 2 pi units away before the next vertical asymptote. Locating the vertical asymptotes, stating the period, phase shift, vertical shift. Oh joy, there's a lot more to this graph. And sketch 2 periods of the function. What am I going to do first, just like I did with sine and cosine? I will, but I'm going to have to factor out the value of b. So this is actually -2 tangent. B is 1/3. If I'm dividing by 1/3 to factor that out, what am I actually doing? Multiplying by 3, right? If I multiply that by 3, that gives me x. If I multiply this by 3, it gives me 3 pi over 6, which is actually pi over 2. So all I've done to go from here to here is factored out the 1/3 or divided by 1/3, same as multiplying by 3. So that's the same function, but now I can see the value of b and h, and I already could see the value of k and a. So using those values, because we're going to come back and answer the other parts where we state all that stuff in a minute. Using those values, what am I going to do to the x-coordinate of my table? Will I multiply it by 1/3? No. 3 times x. Should I add pi over 2? Subtract pi over 2. It's always counterintuitive to what's inside the function. What's outside is what we should do. So for the y-coordinate, we're going to do -2 times y, and then we're going to subtract 1. But this is how we're going to get our final x-coordinate and our final y-coordinate if we know the table for the parent function. So way over here to the right, I'm going to start with my parent function table. My value of x would have been -pi over 2, -pi over 4, 0, pi over 4, pi over 2. My y values would have been undefined, -1, 0, 1, undefined. I've memorized that, but I can get it from the unit circle if I forget. So I'm going to change the x first since that's the hardest one to take care of. We're going to multiply every x by 3. So here's my 3 times x. That's not so bad. -3 pi over 2, -3 pi over 4, 0, 3 pi over 4, 3 pi over 2. Now since I'm going to be adding, or actually subtracting a value from all of these, I'd like them to have the same denominator. It's going to make it nicer to see them equally spaced. So I'm going to convert these two to also be in terms of fourths. To do that, I have to multiply the top and bottom by 2. This gives me 6 pi over 4, -6 pi over 4. The other values stay exactly as they were for now. I haven't done any more transformation, I just converted denominators. So all I've done so far is multiply the x by 3, and now I have to subtract pi over 2 from it. Except, because they're in terms of fourths, what should I actually subtract? 2 pi over 4, yes. Multiply top and bottom by 4. I'm actually subtracting 2 pi over 4. So that's going to give me negative, for my final coordinate for x, I'll have -8 pi over 4, -5 pi over 4, -2 pi over 4, pi over 4, and 4 pi over 4. And then I just want to make sure that those are still evenly spaced. I could see here they were evenly spaced. They were 3 pi over 4 units away. Now that I've subtracted them, they should still remain 3 pi over 4 units away. They are. If If I add 3 pi over 4, add 3, add 3, add 3, they're evenly spaced. That's my final x coordinate. Now I have to find my y coordinate though. And to find my y coordinate, we said negative 2 times y minus 1. Well, if you multiply undefined by negative 2, what do you get? Undefined still. Subtract 1 from it, still undefined. So this is undefined, this is undefined. Negative 1 times negative 2 is 2, minus 1 is 1. 0 times negative 2 is 0, minus 1 is negative 1. And 1 times negative 2 is negative 2, minus 1 is negative 3. So to get those numbers, I did the negative 2 times y minus 1. This is the table I'm going to graph from, but I'm supposed to graph 2 periods, so I don't want to use the full graph. I'm going to just use these 2 pieces right here. If this is negative 8 pi over 4, that would make this negative 4 pi over 4. There's 6, there's 5, there's 7, all negative. 2 is halfway, 1 and 3 are halfway between that. Over here, that makes this 8 pi over 4, because it's the same distance from 0. Halfway would be 4 pi over 4. There's 2 and 6, and then I'll put evenly spaced between those 1 and 3, 5 and 7. So that if I count up 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8 in the opposite direction. Yes, sir.
What was the second transformation for x?
For the x, so we were supposed to subtract, because it was plus pi over 2, we were supposed to subtract pi over 2. And so, but these were all in terms of fourths. So I multiplied that by 2 on top and bottom, and I subtracted 2 pi over 4. 6 minus 2 is negative 8, negative 3 minus 2, 0 minus 2, 3 minus 2, 6 minus 2. So now at negative 8, I'm going to do my vertical asymptote. Also at 4 pi over 4, I'm going to do my vertical asymptote. I'm going to plot my points. At negative 5 pi over 4, I have to go up to 1. At negative 2 pi over 4, I have to go down to negative 1. And at pi over 4, I have to go down to negative 3. This is one period of the tangent function. It looks a little different. Why does it look different? Why is it going up as we go to the left? Who can tell me? Because of the negative 2, that's actually a reflection across the x-axis. So what was going down is now going up. Now these are evenly spaced. Notice that they are 3 pi over 4 units. Every 1, 2, so from here I go out 1, 2, 3 and put a point. 1, 2, 3, put my next point. 1, 2, 3, put my next point. 1, 2, 3, put my next vertical asymptote. Well, I only have enough to get one more in, so I've got to do some more of these. This is 4, this is 8 at this tick mark right here. So this would be 12 pi over 4, and this would be 16 pi over 4 because they're now evenly spaced. 4, 4, 4, 4. Between the 12 and the 8, halfway is 10. There's 9 and 11. Between the 16 and the 12, there's 14. There's 13 and 15. So now I have 16 tick marks from 0 out to 16 pi over 4. To get one more period graph, I have to plot 3 points and another vertical asymptote, and I have to do it every 3 units away since we're in pi over 4 units. So this is 1, 2, 3. So from this asymptote 1, 2, 3, I go up to 1. That's at 7 pi over 4. One, 2, 3 from that, which is at 10 pi over 4, I go down to negative 1. 3 from that, 1, 2, 3. At 13 pi over 4, I go down to negative 3. And 3 from that, 14, 15, 16 pi, I put my other vertical asymptote. If I needed more tick marks, I could add more in, but I don't because it completed the cycle right there, or completed the period right there. Questions on graphing? So working with fractions, lots of fun, right? Trig functions and fractions. All right, see if you can convert the equation for letter B. Oh, we didn't do all the rest. Thank you for reminding me. We were supposed to locate our first vertical asymptote occurred at 4 pi over 4, which is just pi. So my vertical asymptotes are located at, you can put 4 pi over 4 if you want, but it is pi, plus the period times n. The period is pi over b. b is 1/3. Pi over 1/3 is really pi times 3, so it's 3 pi, which we can see that here. This was 1 pi, 2 pi, 3 pi. So 1 pi, 2 pi, 3 pi units later, it repeats. 1 pi, 2 pi, 1 pi, 2 pi, 3 pi units later, it repeats. So this is plus 3 pi n. N is an element of the integers. That's where all vertical asymptotes will be located. Starting at pi, going 3 pi in a positive direction or negative direction will give you the next ones. They asked for the phase shift. We already knew that. Because it was plus pi over 2, we shifted everything left pi over 2 units. They asked for the vertical shift. That was down 1. See if you can find the new equation for this one.